something, right? So let's fill it in really quick. What is the pattern here?
Left times the right.
Hold on, let's do one at a time. Okay. Catherine.
Well, what I did is, like, you can do the left side of the x times the right side of the x, and then you get the bottom.
Yes.
So then you do 16 times 15, and then you get the first part of the bottom x.
Whoa.
Whoa.
They're not connected.
Oh, they're not connected?
You're like thinking a lot harder about this, which is fine, but yes.
Oh, that's awesome.
This 8 times 2, 2 times 8 is 16. How do you get 10?
Add them.
Okay, you add them together. So you take these two, you multiply these two, you get 16, you add them, you get 10. These two, 5 and 3, you add them together to get 8, you multiply them together to get 15. 10 and 12, you add them together, you get 22, you multiply them together, you get 120. So then 6 and 7, you add them together and you get 13. You multiply them together and you get 42. What? No. This is, hold on, okay. It's like a brain teaser. We have to do this type of thinking in the lesson today. So I'm just trying to get your brain ready for this type of thing, okay? This is not really what we're doing. We're doing ones that look more like, turn the page. Not even these, but do you want to fill these in real quick? No. Okay. The ones where you really have to think more is like these in here. Let's do some more. Okay. They have the two numbers here have to add to -5, but they have to multiply to -6. Ideas?
-6 and 1.
-6 and 1. Okay, you need to think of factors of -6 that are going to add to -5. So what are the factors of -6?
1 and 6.
1 and 6. 3 and 2. That's it. So you have, and then there's negative. You have to deal with the negative in there. But if you add them together, it's going to give you -5. If you multiply them, it will give you -6. You want to look for factors of these, -10, that are going to add to 3. Ideas? Alex? -2 and +5 will add to 3 and multiply to -10. Yes. Next. -27. 9 and -3 would add to a +6, was going to multiply to a -27. Yes. What about -17 and -14?
6 and 9.
Noah. 6 and 9 multiply to 54. 4 and -18. -18 plus 4 is going to give you a -14, and yes, they do multiply to a -72. Okay? Do you kind of see the thinking behind what we're doing today? You're going to be given a number. You're going to have to figure out the factors of that number that are going to add to the other number that I give you. Okay? But we're doing this in a trinomial. So, what we've been doing. So, turn the page. If you want to fill in more of those for fun, feel free. Okay. This is the step-by-step method here that I'm going to show you here in a minute. If you like it written out and you want to come back and reference this, feel free. I'm not really going to talk about these, but I'm going to talk about them when we do a problem. Okay? So can we just do that now? You can come back and look at this if you'd like, but we're going to always first you factor out a greatest common factor if possible. So we're going to start there. So section 1. The important thing about these section 1s are that every single time there is a leading coefficient, whatever the front number is the leading coefficient of 1 every single time. All of these have a leading coefficient of 1. So these are easier than section 2. There's also a bit of a shortcut. I'm going to show you the entire method first, the long way, and then we'll see if we can come up with the shortcut, which I think you should be able to do. Alright, so the long method, and I should say, this is really, the kind of formula for this is ax squared plus bx plus c. And all I want you to recognize is that the coefficient of the x squared term we're going to refer to as a, The coefficient of the x term is b, and then this is c, with the signs that go with them. So this is a negative 13, this is a positive 36, and we have a positive.
So it always has to be x squared when it's in the front?
All of these, yes. X squared should be in the front. All of these are going to be, these are quadratic trinomials. So they're always going to look like this if you expect to factor them. There shouldn't be any different kind on the test or anything like that. So, okay. So first step is you're going to take A, which is 1 here, and you have to multiply it by C. So we're going to multiply A times C. And you multiply those together. That's easy. 1 times 36 is 36. Okay. Then you want to find factors of 36. And feel free, you can list them out. Think about what are factors of 36. 6 times 6. Okay. We could go on, and that's fine. But we are looking for factors of 36 that are going to add to a negative 13. Just like we did. Factors of 36. Okay, he's saying 4 and 9. Okay, so 4 and 9. Let me just write 4 and 9 here. 4 plus 9 will give you, if you multiply them together, you get a positive 36. If you added them together, you'd also get a positive 13. But we are looking for a negative 13. So how could you fix this to make it a negative 13?
It's really hard for
I can make it negative 4 and negative 9, right? Negative 4 times negative 9 will give you a, if you multiply them, it will still give you a positive 36, right?
That's what I'm saying.
Yeah, well, that's what I'm saying too. Okay. But this time, if you add them together, you will get a negative 13. Does that make sense? Okay. So now, these are the two factors we're going to use for our problem. And just like 13 or negative 13, they're going to have x's with them. So this is really negative 9x and negative 4x. And if you like to put those there, sometimes I think that can be a little helpful because of the next step, okay? The next step to this, and I think I'm on step 4, we are going to rewrite this trinomial as a polynomial, which just has 4 terms. What we're going to do is instead of using the negative 13, we're going to use our new factors, negative 9x and negative 4x, okay? So in place of negative 13, you're going to use these two factors. So this is just x squared. Now, I don't know if you know, I put a plus sign in between here. This is really important if you've got both of these negative. You can put either one of them first. If one is negative, you usually want to put it first. It's just going to make your life easier a little bit later. If they're both negative, you need to make sure and put a plus sign in between them. So what this is going to look like, let's just do negative 9x plus a negative 4x, and then c is positive 36. Okay? So we've taken our trinomial and turned it into a polynomial, which means 4 terms. And we're leaving a plus sign
So
in
you
the middle.
can switch the two, so it can be like...
You can do negative 4x here and negative 9x there. Yes. Yeah, that shouldn't make a difference. You will still get the same answer. Your work is going to look a little bit different if you choose to do that. Not a big deal, but you'll get the same answer. Okay? So now, the last, is it the last step? Step 5 is factor by grouping. And this is what this whole method is called, is just factoring by grouping. So grouping means you group the first two. You have to leave a plus sign in the middle, and then you group the last two. Okay? Group the first two, group the last two, leaving a plus sign in the middle. That's why I made you put that plus sign there, so you can leave it there. Okay? Then, after you group them, you factor out a greatest common factor here. So, x squared minus 9x, what is the greatest common factor? X. 1x, or just x. And when you pull out an x, what's left?
Negative 9.
X minus 9. X minus 9. You're dividing out an x. So remember, you have to subtract exponents here. And then negative 4x plus 36. We need a greatest common factor here. And because this front one is negative, you really want to pull it out, okay? Because you don't want a front number, or front coefficient to be negative. So it needs to be negative, whatever you pull out, and what's in common here? Negative 4, yeah. So we're going to pull out a negative 4. We don't really need the plus sign anymore if we have a negative there. And then what's left is x. Now, since we pulled out a negative, it's like taking 36 and dividing it by a negative 4. So that's going to leave us with a negative 9. Okay? We're just smidgens away from
How
the
come you
answer.
didn't put the negative 4 inside the parentheses?
I pulled it out as a greatest common factor. I like pulled it out. Okay? Yeah. Good question. And then the last thing, and this is a good check for yourself. When you get to the end, these parentheses, whatever's in the parentheses, should be the same. If they're not the same, you've made some little mistake. Either you didn't factor out the greatest common factor, maybe you factored out a common factor, just not the greatest one. Or, like if we hadn't pulled out this negative, it wouldn't look the same. So that's also something to look for. But the parentheses have to be the same. And then your answer, and I'm going to write it over here, is, well, okay, think of this way. This might be a little difficult, but I want you to think about this. This right here, think of this as a term, okay? And it's being subtracted from another term, right? What do these two terms have in common? What is the greatest common factor of these two terms? Not just negative 9.
X.
They all have an x minus 9 attached to it, right?
Right.
So if you think of that as the greatest common factor and you factor it out, say you pull out an x minus 9, right? What is left over?
X plus 9.
If these are both gone now, you've pulled them out, they're gone.
X minus 4.
X minus 4 is what's left. Is that okay? The other way I say it normally is that you take whatever's inside the parentheses, you write it once. You take whatever is in front of the parentheses, like here, and you put that together as your other answer.
That was so much easier when you explained it.
Okay.
I know.
I was just trying to get all deep on you, that's all.
Yeah,
So
when you
anyway,
went all
okay.
deep, it went,
Okay. Again, whatever's in the parentheses is written once as your answer. Whatever's outside the parentheses, and normally I do like, you put this in one, and then x minus 4 is the other part of the answer. Okay? Now, that is the long method. There is a shortcut when the coefficient is 1. So these are a bit easier. You don't have to go through this whole process. I showed you the process because we are using it in section 2. And I wanted you to see what we're going to do in section 2, but easier. Okay? Because it's not hard. I know, Victoria's back there freaking out. But, okay, so what's the shortcut? What do you see? At what point could I have stopped and said, whoa. Here's my answer.
You told us this already.
Where?
I don't know.
Very good.
Tori, you just left.
No, not the very end.
Is this like the last thing that we did before?
What's that?
When we got our factors, what were they?
13.
There you go.
Oh.
Negative 9 and negative 4. X, negative 9, X, negative 4.
O-M.
so we
Wow.
oh my god.
So basically we could have stopped here
Are you kidding?
and used the short. We can't do that on the next ones.
Okay, fair
Okay? Which is why I wanted to show it to you on an easy problem. And then let's use the we can use the shortcut method from here on out here, okay? But when we get to section 2, you have to do all of this. So that's why I wanted to show it to you, okay? Okay, so I gotta erase this because
Where did you get the 13 from?
okay, where did I get the 13? Good. 13 is the B.
Oh. But the 30. Oh, never mind.
Yeah, they have to multiply to 36, or they're gonna add to whatever B is. They have to add to whatever B is. Good. Okay? Other questions? Okay. I need to write my answer somewhere better.
That was crazy. I just got mine. 1, 2, 7.
Okay. This one. Ready?
No.
Shortcut. We're doing the shortcut.
Okay,
Yeah.
Oh, no.
Oh.
Yes.
Wait, isn't there a back button?
Is there?
I'm
Yeah.
It's too late now that I've written.
See the
A
arrow?
little arrow right there. Yeah.
Right.
Oh.
No.
I'm a genius.
Thank you, Brian. That was genius.
Oh my.
Man, that was sad. Okay. Okay. Again, A times C. 1 times 72 is...
72.
72.
Oh, so difficult. Good. Okay. 72. Then we need factors of positive 72 that are going to add to
9 and something.
9 and 8.
17. What are factors of 72 that are going to add to 17?
9 and
9 and
8. 9 and 8.
9 and 8.
and they add
9,
to it.
9 times 8 is 72. 9 plus 8 is
24.
17.
I was close.
Okay, these are the factors we're going to use, okay? And now, we can jump down to this. Those are the, because it's a leading coefficient of 1, once you've got your factors, those are really the answers. So, you can jump down here and say, they're both positive, so this is going to be x plus 8 and x plus 9. And that's your answer.
I like that so much now.
Why do we even do this?
I already said it like 3 times, so if you didn't hear it, sorry.
So if you can only, it's only
In the
have
next
a,
section, we're using that.
coefficient.
What's the total?
The number in front of the variable is a coefficient.
Alright, next one. Ready? 1 times negative 12 is good. Yes, really. Okay, we need then factors of negative 12 that are going to add to negative 4.
Negative 6 and 2.
Okay, negative 6 plus 2 will give you a negative 4. So we need these two as our answer. So you just write them. 6 is negative, so x minus 6. 2 is positive, so x plus.
So the inside things would be different. Like one could be plus one.
Yeah. They don't have to be the same. They can be, they're whatever you end up with here.
Oh, okay, that makes sense.
How would you check your answer?
Plug it back in.
I'm mind blown.
Plug what in?
Well, I was thinking you could just.
You simplify it.
You could reverse.
What are we doing?
False.
You distribute it.
You multiply these two
Oh,
polynomials
you
together.
do the
X
x to the x.
times x is x squared.
Can I come up there and do it?
No,
I have a question.
Brian.
Is that going to be like that for like every problem that we do? Like that shortcut will work
No.
for everything?
No.
You're right.
Only with
Only
the
with the
coefficient
one.
of
Okay.
one.
1 and
The
a
fact that the leading coefficient is a 1 means that you can use the shortcut. Everyone on section 1 has a leading coefficient of 1. Okay? And really, we should be checking all of these for greatest common factors. But they don't have them, so I haven't been doing that. Okay, I will do it on the next section, because those do. So, okay. Brian, does that help? Does that make sense?
Yeah.
Okay. Okay. Last one, 1 times a negative 24 is,
Negative 24.
Negative 1.
we need factors of negative 24 that are going to add to a positive 10. Leslie?
Oh, never mind. I was going to say negative.
They're not the ones you immediately think of.
Negative 6 and 4.
Again, they're not the ones you know.
Wait. Not
Negative 6 and negative 4 would add to a, would multiply to a positive 2.
Oh, sorry. 6 and 4.
Negative 12 and positive
Yeah, Leslie's got it. Negative 12,
Positive.
positive 2 would add to, no. We did a positive 10.
Negative 2 and positive 12.
Okay. Negative
Let's go!
2. Austin. 75% of yourself. Not 100%.
That was like 12.
Negative 2 plus 12 is positive 10, and that's what we need. Okay, so these are the two factors. So because it has a leading coefficient of 1, the trinomial does, you can use the shortcut. So x minus 2, x plus 12. And order doesn't matter here. You can switch these around. Okay? Order doesn't matter. Okay. Section 2.
We just skipped this section.
Well, I haven't done
We
anything.
love you.
Okay, skip the section. No,
Miss Sturgeon hate me today.
I didn't put that up there.
I did.
Off mine.
What is it?
Sorry.
What is it?
Okay, next page, section 2. Okay. So now we have leading coefficients of 3, 6. Okay. So these are not leading coefficients of 1. So you have to use the full method. Okay. The fact it's called factor by grouping. Okay. I've already kind of told you that. But for these, you really want to make sure that you've checked for a greatest common factor. It will make your life easier if you do it first. You can do it in the end, but it's a little bit more complicated. Okay, so greatest common factor. Is there a greatest common factor here?
No.
9 and
9 cannot be the greatest common factor because they have to be less than the lowest number. 3.
Wait, but it's negative 36.
Use your calculator. Does 3 go into 36? Does 3 go into 81? Yes.
If
Okay.
it goes to 36, it'll go into negative 36.
So, what's left?
That's a 3.
1.
X squared.
X squared. X squared minus, you're pulling out the greatest common factor. 3. 12. X plus,
Wait, I'm 9.
some people are saying it. 27. Okay, look what we just did.
I love it.
We had a leading coefficient of 3, which would have made our life miserable. But now what do we have? A leading coefficient of 1.
Wait, 3.
We can use the shortcut on this one. Okay, so you leave your 3 out front. Well, okay, 1 times 27 is 27. We need factors of 27 that are going to add to negative 12. Negative 3 and a negative 9 would add to a negative 12. Good. Okay, so these are our two, answers. You have to have the 3 on the outside, but you can do, x minus 3 times x minus 9. And we can use the shortcut because it had a leading coefficient of 1. Because we factored out the problem. Okay, so it's so simple, but so hard. Okay. Okay. Next one. Is there a greatest common factor here?
No.
6, 31, and 5. Yeah, it's a greatest common factor of 1. So we don't do anything. We have to use the full method here. Okay, remember it is, you use A times C. So that's 6 times 5 is 30. Okay? And then we need factors of 30 that are going to add to 31. Not impossible.
30.
1 and 30.
30 and 1. 1 and 30. Yeah.
Smart.
30 times 1 will give you 30, but if you add them together, they will give you 31.
Oh, I didn't know that.
Okay. So now we have the rewrite step. So we're going to rewrite this trinomial. We're taking out the 31, and in its place we are going to do 30x and 1x. So if you want to put your x's here, sometimes that's kind of helpful. It was 31x. We're going to change it to 30 and 31. So rewrite. So 6x squared And it doesn't matter which one goes first, since they're both positive, it's easy. So, which one do you want to put first?
Positive.
30, good lord.
30, okay. So plus 30x, you need an x there, plus 1x, or just x, and then plus the last term, which is c, 5. Okay, so we rewrite the problem using our two new factors. And then we factor by grouping. We group the first two, leave a plus sign in the middle, group the last two. So we group 6x and 30x, leave a plus sign in the middle, then x plus 5 is in the second set of parentheses. And then you have to look for greatest common factors of each set of parentheses. So what is the greatest common factor between 6x squared and 30x? 6, what else?
No, 6x.
6x. So we're going to pull out a 6x. What's left? X plus 5. What did I tell you about the parentheses? Okay, never mind. What's the greatest common factor here? 1. You do have to put a 1. So we're going to pull out a 1, but it doesn't change anything, right?
Do you have to write it anyway?
Yes. Yes, you have to write it anyways. What I told you about the parentheses that you didn't remember was that the parentheses have to be the same. So when we got done factoring this greatest common factor out, did you notice that it was the same as this one up here?
Oh, yeah.
So like already, like all we had to do was pull out a 1 and then we had the same thing.
Wait.
So the parentheses are the same, so we did everything correct.
How did you get the 5 on the first one?
We pulled out a 6x. 30x divided by 6x. 30 divided by 6 is
5.
5.
Oh, okay.
X divided by x is no x.
I see that.
Okay, just 5. Does that make sense? Okay. Alright, and then your answer is whatever's in the parentheses written once, so x plus 5. And then whatever's outside the parentheses put together, so that's 6x plus 1. And if you put these in the other order, that's fine, that doesn't matter. 6x plus 1 can go first. Okay? There's 2 more.
Oh gosh. Oh.
And for the video purpose, I'm going to do all of them. If you want to get ahead and try some on your own, feel free.
For free.
What?
For free.
What did I say?
I think
Feel,
you said, yeah.
feel free.
I was like, oh, I didn't know the penny.
I'm not gonna go.
Yeah. Good question. Katie?
Man.
Austin, volunteers.
Yes, I volunteered.
That's tribute.
Okay, we're almost done. Let's hurry along.
Do we have that section?
Yeah.
Oh, it's distributed practice.
Distributed practice is what's left. So keep going. No. No. Okay. A times 6 times negative 6 is negative 36. We need factors of negative 36 that are going to add to 5. Negative 4 and a positive 9 will add to a positive 5. Yes, Tori?
Okay. I totally understand, but why on the first one did you multiply?
What? We did.
Negative 4 times
From the very first one.
Oh, we did a shortcut.
Well, they multiplied to a negative 36, but we need them to add, so I did both. I mean,
When did they
I know
multiply?
I'm not writing out both, but we are doing the same thing in the head that we did earlier. Like this will equal a positive 5, which is what we want, but they're going to multiply to a negative 36. I'm just not writing all of that out, and I understand that might be a little confusing. I think you're right. I did multiply them the first time and then showed the addition, but it took up too much space, so I'm trying not to use as much space anymore. Okay. Okay, so these are our factors. I'm going to put x's with them because we're going to rewrite now. In place of 5, we're going to write the negative 4x and the positive 9. And because one of them is negative, I'm going to write the negative first because it makes it a little easier to do that. So negative 4x plus 9x, again, in place of the 5x, minus 6. Okay? And then we're going to group the first two, group the last two, leave a plus sign in the middle. So group the first two, leave a plus sign, group the last two. And then greatest common factor in each parentheses. So what is the greatest common factor here?
3x.
Not 3. 3 does not go into 4. 2x. 2x, and then what's left?
2.
4x. No, 3x.
We're dividing. We're dividing here. 6 divided by 2 is 3. Not 4, not 2. 3. X.
It's 4, yeah, I
We
heard
pulled
that.
out 1x. We pulled out 1x, so there's 1 left over. Okay? Come on, I can't do this. If there's a lot of feedback on this video, second hour is going to be mad at you. If you pull out a 2x here, what's left?
2.
Wait, pull out a what x? 2. 2x. Okay,
Out of a negative 4, negative
Negative 2. No x.
I said that.
What's the greatest common factor here?
3.
3. Plus 3. Put a plus there, because later you're going to put it together, and you need a plus. You can't just put numbers and variables. You need operations as well. And then what's left over after you pull out the 3?
3x.
3x minus 2.
Or 2.
2. Again, your parentheses are the same, right? That means we did it right, okay? Your answer is whatever's inside the parentheses times whatever is sitting outside the parentheses. So 2x plus 3. That's your answer. Okay? Yes?
So when we, when you say take out a 3, are we minusing or dividing?
Dividing.
Dividing. Okay. Next.
You said minus.
8 times negative 3.
Oh, wait.
Negative 24, new factors of negative 4, 24, that are going to add to negative 10. Negative 12,
No, it'd be negative 2 and positive 12.
the negative 12 plus 2 will give us a
Oh,
negative
wait.
10.
Never mind.
We need a negative 10 here. This gives us a negative 10. Okay, so these are our factors. If you want to put x's with them, sometimes that's helpful. And then rewrite. 8x squared, and one of them's negative, one of them's positive. Thanks.
Yes. What?
You could at least like duck underneath it. Minus 12x plus 2x minus 3. Did you see what I did?
Yeah.
Okay, group the first two, leave a plus sign in the middle, group the last two. Factor out a greatest common factor here.
X. No. Yes.
Well, x, but there is a number.
No.
4 and x. What's left if you divide that out?
A negative
2x minus
3.
3, no x. Okay, what do you notice?
Same thing.
They're already the same, so what's the greatest common factor here?
1.
Yeah,
No.
so plus 1, and then all that's left is 2x minus 3, the same thing, that's already.
Straight.
Okay, and your answer is whatever's in parentheses, written once, and then whatever is outside the parentheses, 4x plus 1. Okay? It works every time. That's what I love about this method. It literally will work every time if this factor is. It will work on those perfect square trinomials. It will work. It actually does work on on the difference of two squares too. It works on all of that. So if you just know this method, you can factor anything basically, as long as, now there are some things that cannot be factored, but I don't think we're gonna run into any of those, so we have it on our notes, so we try to be good about that, but anyways, okay. Distributed practice. Let's see how much of this we can quickly get done. I know there's not a whole lot of time left, but we can handle it, right? Okay. With these are being multiplied, okay? We've got 3 square root of 5 times -8 square root of 7. Rule is that you multiply anything inside with inside, outside with outside. So anything outside the radical can be multiplied together. So 3 times
-24, sorry.
Mackenzie.
My bad.
3 times a -8, yes, right, is a -24, and then you multiply anything inside together. 5 times 7 is 35. Okay? Then, you look at 35 and decide if it can be broken down into a perfect square. What are the factors of 35? 5, 7. Both are prime, so there's the rule for square root, you have to have 2 of something in order to pull one out, right? Yes?
Yes.
Okay. So there's not 2 5s, not 2 7s, it's just 5 and 7. Other factors of 35, 1 and 35, beyond that, I don't think there's anything. I think this is as simplified as it gets, so it's possible that it would just be that. Maybe half the time, okay? The other half, it's going to look like this. So this one, we've got inside it, or sorry, those are outside. -5 times 2 is -10. 12 times 6 is 72. Can 72 be broken down into a big perfect square? 9 goes into it. Okay, do you like, let me remember, okay, we did 2 things. I taught this once where you pulled out the biggest perfect square, and then I taught it where you broke everything down into prime numbers and picked 2 of something. Do you remember which one you like?
I like the one that wasn't the prime, because you taught us that last.
Yes, I did teach that last.
Don't do that.
Okay, so what is the biggest perfect square that goes into this? Remember what your perfect squares are?
Yes, I do.
9 is not the biggest.
16.
16. Do 72 divided by 16, what do you get?
4.
16 and 4?
4
I got 4 1/2, so I can't 4.
I got 4 1/2 too.
Oh, then it doesn't work.
What up? I'm a genius. I knew that 4 in.
Anyways.
Wow.
18 is not a perfect square though.
I'm halfway
It's
right.
9? But it breaks down more than that.
36.
Thank you, that's it, yeah. Oh, alright. 2 times 36. Okay? Is that okay?
Yeah.
72 breaks down, the biggest perfect square is 36. Then, you cannot square root 2 because it's prime, there's no other 2 to match with it. What though is the square root of 36?
6.
6. So, you have a 10 outside, you get to bring a 6 outside because that's the square root of 36, right? All that's left inside is just a 2, and you can't do anything with that, you just leave it like that, okay? But, you can multiply the outside. -10 times 6 is -60 times the square root of 2. That's the answer.
This is the prime.
Yeah.
It's always gonna be negative on the outside.
Divide by 2. Square root of
Okay. These. You're trying to get x squared by itself. So, I don't know if you just heard Tori said divide by 2. So you get x squared is equal to
49.
49. And then square root both sides. These are the ones though that have 2 answers. So x is going to be equal to plus or minus 7. You have to have both answers in order to get this correct. Okay? You can do the same thing here. Now, multiplying by 1/4. I know you think you might want to divide by 1/4. But multiplying by 1/4 is the same thing as dividing by 4. You know that? So you can multiply this by 4/1. sides, or just 4, and the 4's are going to cancel out, and it's left with y squared is equal to 16. Then square root. Y is equal to, that's half of the answer, but not going to give you full credit. Plus or minus 4. Okay, let's keep
Square
going.
root 2
And
on top and bottom.
you have to rationalize the denominator. So you have to multiply by whatever is in the radical on top and on bottom. Don't pack up.
Yeah, you folks.
So remember the rule. If you waste this time, it's fine, but we're going to have to do more on Friday, and I don't know when I'm going to be here Friday, so you need to, like, get ready for this. Your test is Monday.
Monday.
Joy.
Yeah, you want to pick up a review on your way out the door today. So listen. You multiply outside with outside, so it's a 1. You multiply inside with inside, which is just square root of 2. On bottom, you're going to have the square root of 4, because 2 times 2 is 4. But what is the square root of 4? 2. The last thing you look for is can 5 over 2 be reduced? In this case, it cannot. 8.4 is your homework. I love you guys. And I was going to shorten it, but I don't have enough time to tell you. So, yes.
Ouch, my homie.